All right, can we go to worksheet 3,
Sure.
please? And then can we do number 11?
Sure.
G.
Okay.
Because like I know how to do most of those ones. Because I know you said know how to graph for the quiz or whatever.
Yeah.
Okay. I have questions. Just go on.
Okay.
Sorry.
So I'm going to start by finding the values for A, C, H, and K, because I need those to complete the amplitude, the midline, to write my map. So I need that for everything. The first thing I'm going to check before I go looking for those is to make sure that my equation is in the proper form, which I notice that it's not, because the leading coefficient on x is not 1. So I'm going to start by factoring the inside part there. So I'm going to take the 2 out. When I'm factoring something off like that, I'm dividing. So 2x divided by 2 is x. And then pi over 2 divided by 2 is the same as pi over 2 times 1/2. So that would be pi over 4. And then I'll write the plus 0 at the end. So I have A, C, H, oops, and then K. So far, so good? Okay. The amplitude is the absolute value of A, so that's 3. The midline is y equals K, so that's y equals 0. The period is 2 pi times the absolute value of C, so that's just pi, and the frequency is the reciprocal of the period, so 1 over pi. Joe?
Okay, so for the period part, that's the part that confuses me. So when you say, is that just like the universal formula?
Yep.
It's 2 pi times the absolute value of C?
Yep.
What is F again?
Frequency?
It's just 1 over.
It's just the reciprocal of the period.
Over, okay. So A is the same. What is it? Midline? How do you find the midline?
Y equals K.
Okay. Will we get these reference points on the whole?
These are things that we've really needed to do to be able to do almost any problem that we've done so far. So these 4 little formulas are things that you should know.
Okay. So when you factor out the 2,
Uh-huh.
that doesn't change the value of C. Still take the value of C as if it was attached to that X, right?
You could get the value of C as if it was attached. Sure. The thing that you'll mess up is the H.
Okay. So you got C equals 1 over 2, and then you factored 2 out? Or you're saying like there's another process to do to get C?
No, the issue is the H. So that's the thing that you'll mess up if you don't factor first. But before I do anything is I just factor rather than pull some of the numbers and then factor, because I would be the kind of person who would just get in a hurry and forget to factor, because I'd have to change halfway through. So I just factor first and then I pull my numbers. You know what I mean?
Yeah, and if it's a -2 there and not a +2, do you factor out a 2 still and leave it at the coefficient is -1, or does the coefficient have to be a +1?
Has to be +1. Okay, so now that I've pulled those values and I completed that first part of the problem, I'm going to go ahead and write my transformation map. So the transformation map we're using is always going to be Cx plus H, and then AY plus K. So I'll fill in those values that I have. So my C is 1/2. My H is pi over 4. My A is -3. And I'm not going to write plus 0 for the K. I'm just going to leave it there. Then I'll go to my notes here. And it must be this one. Yep. And I'm going to pull the key values for sine. So I'm just going to copy those down. Again, those would be something that I would give to you. You do not need to memorize those.
But we should memorize the C and X plus H.
Yeah.
AY plus K.
We were working with that for so long.
Yeah. I think that that's not unreasonable.
Just like BX. It's easy. Don't look at me like that. No, I still.
So I've gone ahead and copied in my key points. Now all I'm going to do is take my X and plug it in for the X spot, take my Y and plug it into the Y spot, and evaluate. Okay with that? I do the next one. That's pi over 2 and negative 3. And 3 pi over 4 and 0. And then pi and 3. And 5 pi over 4 and 0 again. Any issue with the arithmetic there? Just multiplying and adding fractions or whatever should be pretty doable, right? If you get stuck, just use your calculator, drop the pi's off, and use your calculator to do it, right? Okay, so now I'm going to plot my points. So if this is 0 and this is pi, that spot must be a half a pi. So like that's 1/4, 2/4, 3/4, 4/4, 5/4, etc. So I'm just going to plot my points based on that. So I have 1/4 0, a half negative 3, 3/4 0, pi positive 3, and then 5/4 0. So if I draw that one period, there's that. And all I'm going to do now is just extend this graph to fill the space. So I'm just going to kind of follow the same pattern. So I would go to a minimum. Oops, let's use a different color. Back to the midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum. And the same thing on to the left. So maximum, midline, minimum. There's my picture.
All those zeros. John, go ahead.
Okay, this is a general question. So for P, like you said, it's 2 pi times the absolute value of C, right? And then from there, once you figure out all your little points, you do that XY, CX plus H, and then AY plus K. And so what you're plugging into the C and the H and the A and the Y's are like the C, A, those values, right?
Correct.
Not the A, M, P, F.
Correct.
And then,
Those numbers at the top are never used again.
Right, right. Okay, cool. And then you just plug it into the things that you're going to give us, like the sine or the cosine.
Yep. So you just use the key points to plug into your map, and then you get your new points, and you plot your new points.
Just graph it, call it.
And just extend it following the same pattern, because it just does the same thing over and over and over again.
Cool. Okay, thank you.
Rami?
Why are there more zeros, or like, more points on the midline than are plotted on the right?
Well, I have 3 midline points, and then 3 midline points.
So what's in blue?
That's just me extending the graph. Like that's more periods. So I'm just going to plot one period because the graph just does the same thing over and over and over again.
Okay.
So I'm just going to do one cycle, and then I'm just going to follow the pattern and just keep doing the same thing over and over again.
Same distance between every.
Yes, same distances between every point, same like height for every point, same order of the points occurring. Nothing else changes. Once I have one cycle, I can just keep.
So should we graph like the entire graph with the cycle, or just one?
Yeah, you should really fill the space. Okay, who's next?
Oh, I have a question.
Yeah, what's up?
Wait, does anyone else have questions? That one? No? Okay. I have a question on homework 4.
Sure.
It made like 0 sense. What are these sinusoids?
So that's just a sine or cosine function. So when we say sinusoid, oops, I shouldn't write it here.
Sounds like
Let me just pull one of these things. Oops, there goes my stylus. Okay. So when we say sinusoid, we mean that we want either an equation like this or an equation like this. One or the other, doesn't matter which one. For each of these, it's possible to, it's possible to do either for each of them. In fact, there's infinitely many answers for each of them. The trick will be to not have to do it the hardest way possible.
All right.
Rami?
Would the points that you transform be like reverse if you're using cosine, or what's the difference?
Kind of. It's not reverse, but the points you're using when you're looking at your transformation matter as in terms of which one is going to be easier, sine or cosine. So if you want to go through a specific one, we can talk about kind of how I would approach that. I'm happy to do that. Well, here's the thing. Depending on the situation, I'm going to pick some of them I'll do as cosine, some of them I'm doing as sine, because they're easier in some cases to do one versus the other.
Easier based on what?
The kinds of point that you're given. So for cosine, what you want are maxes or mins, and cosine you want, or for sine you want midpoints. So if I'm given a midpoint, I want to use sine. If I'm given a maximum or minimum, I want to use cosine. That's going to be the easiest way to kind of deal with that problem.
How are you given, like, you're given the midline through K, how would you be given a maximum or minimum? Is that
so like, here, like look at number 4. I'm given an amplitude, a period, and then that it has to have a minimum at that point. So that's a problem I would definitely use cosine to do because I'm given a minimum. If we look at...
does construct just mean create an equation?
Yes. Yes, exactly. So if you look at 5, I gave you a max and a min. I'd use cosine to do that one. 6, I gave you a min and a max. I'd use cosine to do that. In 7, you have a midpoint and you also have another extrema. There you could use sine or cosine. It wouldn't really make much of a difference. They're about the same. Does that feel better?
Yeah.
The trick here is for like 1, 2, 3, where you're not told anything about the points. What should you do? You use sine. Yeah. So you can make all of the, it's not wrong. You're just not doing it the easiest way.
Okay.
Right? Like you can do it with cosine. It's not that much more difficult, but it's a little bit more. I would do sine because you get the h and k for free if you use sine on those ones. You get both h and k for free.
Okay. For
cosine, h is free, but k you have to solve a little equation to get. So that's what I mean by like easier than one way versus the other.
These are the problems where it's like, if it's like sine, it's 0, 0, and we use the 0 as the
so
the h value.
So that's how we're going to find the h, is we're going to compare a point from the parent function to one of the points in our transform function to figure out the h. And sometimes we'll also have to figure out the k that way.
Okay.
Yeah, do you want to do one of these?
Oh yeah, can we do one?
Sure. I know we've asked a lot of detailed big picture questions, but
Can we do one? I
Sure.
really don't know how to do this too well.
Yeah, that's fine. Do we have a preference on which one you want to do?
I don't know. It's up to you. They kind of seem similar. Number 3 has a lot of points to it.
Well,
No, it doesn't.
3 is the one tricky one where I'm forcing you to use the point that you wouldn't really want to use, or the function you wouldn't really want to use. I would prefer to use sine on this one, but I'm telling you, you have to use cosine, so it makes it a little bit harder than it needs to be.
Let's do number 2 then.
Okay,
Just
Riley, what's up?
idea.
Yes, of course.
Get the
Okay.
idea down.
Sure. Okay. So you remember those little formulas that we talked about on the previous problem about how to find the amplitude and period and all that stuff?
Yeah.
We need them here.
Okay.
So I know that the amplitude is the absolute value of A. So I know that in this case, since the amplitude is 12, the absolute value of A is 12. I know the period is 2 pi times the absolute value of C. And since the period here is 8, I can divide both sides by 2 pi to get the absolute value of C being 4 over pi. And so if I say the absolute value of A is 12, that means A was either negative 12 or positive 12, right? And if I say the absolute value of C is 4 over pi, then I mean that C was either positive 4 over pi or negative 4 over pi. Still cool? Okay. So there are correct answers where either could be true, where A is positive or negative and C is positive or negative. We're going to choose to find the answer where C is positive every time. It will never be the easiest way to do it to make C negative. Sometimes it'll be like the same, whether C is positive or negative. But I'm just going to always pick C to be positive here. Okay with that?
So you just did the reciprocal of it? Is that the word to use? You just did 4 over.
I still had 4 over pi. I'm just picking C to be positive 4 over pi instead of the absolute value of C. So I've solved for C, basically.
Yeah, okay. You're good.
Stephanie.
Could you explain that again?
Yeah. So C, or the absolute value of C, is 4 over pi, right? So that means that C could be negative 4 over pi or positive 4 over pi. There are correct answers in which both is true. I'm going to always find the answer where the C is positive because it's never the hardest way to solve the problem, right? Sometimes making C negative could be just as easy, but it's not going to be easier. So I'm just going to always find the answer where C is positive every time. Is that okay?
Yeah.
And that's preference. It's not like you have to do it that way, but it's like, I'd encourage you to do it that way because it tends to make life a little bit simpler. Still doing okay? All right, so we figured out C. We need to find H, K, and the sign for A also. Everybody's okay with that? So I'm going to do that, and we have to figure out whether we're going to use sine or cosine. Okay? So I'm going to, since we're given this point, and we're not told anything about this point could appear anywhere on my sine function. It could be a maximum, it could be a minimum, it could be a midline point. It doesn't matter, right? I can choose where to put it. Is that okay? So I'm going to choose to put it on the midline because using sine, then I can use sine as my function. And the midline point for sine, one of them is 0, 0, which makes the computation for H and K really simple. So that's what I'm going to do. So I'm going to pick to use sine. And I'm going to pick to use the point 0, 0, which is a midline point. And I'm going to pair that up with the point 3, 5, which I'm also going to make a midline point. Now keep in mind when we're doing this transformation, I have to pair up a midline point with another midline point. Or a maximum or minimum has to pair with a maximum or minimum. Now max can pair with min and min can pair with max, or they can pair together. That's okay, but an extreme point, a high or low, has to pair with another high or low. If you think about what we're doing, we're pairing these things in a transformation. So like something in the middle can't all of a sudden become the highest point in the function because whatever you did to it, you have to do to every other point in the function. So like the high points would still need to be higher than the midline points, right? If you did everything the same. Is everybody okay with that idea? Okay. Now, there's one other piece that we have to worry about here with these midline points, is there's actually two kinds of midline points. if I look at the graph of sine, it kind of looks like this. So this is the midline point 0, 0. Everybody's okay with that? To the right of it is a maximum. Okay? This, let's use a different color, is another midline point. To the right of it is a minimum. So there's two different kinds of midline points. There's midline points where it's followed by a maximum, and there's midline points where it's followed by a minimum. Just like there's two kinds of extreme points. There's maximums and there's minimums. Okay with that? Now, for sine, just y equals sine x, 0, 0, the midline point, is the, I'll just call it midline max. That's the kind of midline point it is. It's the one where the maximum comes after the midline. Everybody's okay with that? 3, 5, we're not told what kind of midline point it is, right? So I could choose. I can make it a midline max or I can make it a midline min. It doesn't matter. Both would be okay. Let's say that I chose to do midline max. Because these parts are the same, that tells me that the A coefficient is positive. So my A in this case is 12. If I had chosen to make 3, 5 a midline min, then A would have to be negative. Everybody's okay with that? Okay. I can find the H for free. Since the x-coordinate in my parent function is 0, the x-coordinate for my transform function has to be my H. Likewise, since the y-coordinate for my parent function is 0, the y-coordinate for my transform function has to be my k. And now I have everything I need to write my equation. So A times sine of 1 over c, so I'll just write the c as a reciprocal, x minus h plus k is one possible answer. So again, if you had chosen to make 3, 5 a midline min point, the A would be negative. That's still a fine answer. Everything else would have stayed the same. If you had chosen to use cosine here, then the h and k could be different, and well, the h would be the same, but the k would be different, and the sign for A might be negative. Could be. Maybe it wouldn't be, depending on what you did. If you had chosen to use some point other than 0, 0, that'd be a poor decision because you're making your life a lot more difficult than it needs to be. But if you did that, the H and K and A could all possibly change. Leo?
Is the C supposed to be pi over 12 or pi over 4?
It should be, pi over 4. Thank you. I don't know where I got the 12 from. Probably looking at the A. So really the only tricky part was, only weird part was this piece, right? The other pieces were just like solving little dinky equations. But really what it's coming down to is if I picked sine, immediately I have my H and K right there, right? 3 and 5 are my H and K, have to be. And in this kind of problem, the sign for A didn't matter. I could make it positive or negative. Either is okay. Now, that won't always be the case. Some of these problems are more specific because we say that the point has to be a maximum or a minimum or a midline point. And then things get a little bit more difficult. And there's not so many answers. But this one could be one that conceivably, once you understand what's going on, you can mostly do in your head. You guys want to do another of these? Yeah. Do you want to do like one like number 4 where we're specific about the kind of point it has to be? Okay. So again, the amplitude is 3, so I know the absolute value of A is 3. The period is 5, so I know 2 pi absolute value C is 5. So if I divide both sides by 2 pi, absolute value of C is 5 over 2, and we're always going to pick the C to be positive. So far, so good. Because we're dealing with an extreme point, a maximum or minimum, I'm going to use cosine, or I'm going to write a cosine function. So from the parent function, I'm going to pick, I need to use an extreme point. The extreme point I prefer is one where I have zeros in my x or y coordinate. The only one I can choose there is 0, 1, because there's no extreme points that have zeros in their y coordinate. And that is a maximum point, right? If I looked at the parent function of cosine, 0, 1 is there, right? It's a maximum. Everybody's okay with that? That's always the same, right? Because it's from the parent function, so the parent function stuff is always the same. From the transform function, we're going to pick the point, or we're using the point, we're given the point, I should say, 5, negative 6. And we're told that point is a minimum. So if I compare the type of extreme point, those are the opposite types. So that tells me the A is negative. So I know my A is negative 3. Is that okay? To find my H, since the x-coordinate of the parent function is 0, the h is just the x-coordinate from the transform function. That's 5. The tricky part on this one is now going to be finding the k. Note that the x, or the y-coordinate for my parent function is not 0. So the y-coordinate for my transform function is not k. How will I find it? Well, here's my explanation. So remember when we're graphing things, we have this transformation map, right? Like we just graphed something a few minutes ago. So what we're doing is we're taking a point from our parent function, multiplying it by c, adding h. That'll give me my new x-coordinate. And then I plug in my y-coordinate from the parent function, multiply it by a, add k, and that gives me my new y-coordinate. Everybody's agree with that?
Are you doing that with the parent function, you said? Or the transform function?
Yeah, so let me write it down specifically, because we're doing this for the y-coordinate is the one that we care about, right? Because we need to figure out k. So what we're saying is I take my y-coordinate from the parent function, I multiply it by a, and I add k, and that'll give me my y-coordinate in my transform function. Right? That's how we use that transformation map. So I'm going to fill that all in. My a is negative 3. The y for my parent function is 1. K is what I'm looking for. And the y for my transform function is 6. So I have 1 times negative 3 is negative 3. So I add that to both sides. So k is negative 3. And there's everything I need. So I'll say y equals negative 3 cosine of 2 pi over 5 times x minus h plus k. Yes, of course. This is the hardest thing we do in chapter 3, just FYI, are these kinds of problems. So just to let you know, it doesn't get harder than this in chapter 3.
cosine's harder than sine.
Can be. Sometimes it's not. Sometimes finding the k isn't as bad as this one is.
There's 7 sections. Have we done 7? Have we learned 7 things?
No, there's not 7 sections. There's 3 sections. In the regular class, we only do 2 of them.
Oh, okay.
But we've had really like 3 worksheets from, or 5 worksheets from section 1.
Okay.
So worksheets 1 through 5 are all coming from section 1. That's all we've done so far, section 1.
Oh, damn.
Section 2 is not much more.
Okay.
Because it's really doing the same thing over again. So like all the skills are the same, just the function you're using is different.
Okay.
So like all the formulas are relatively the same. The processes are like all the same, with just like little minor modifications for the new function you're using. So it's not
harder than this.
It is not harder than this. Do you guys want to do some more? You got some more questions, Ellie?
Worksheet 5, question 1.
Worksheet 5, question. Which one?
1 is
1?
Mm-hmm.
Sure. Again, if I'm going too fast or anything, or if I do something you're not sure about, or if there's some follow-up that you want to ask about, please stop me and ask. Okay. So these problems here are basically the same thing as the previous problem, but they're a little bit easier because you have more information, right? You essentially have all of the points on your graph. You have maxes, you have mins, you have midline points, you have everything that you might want. So the way I like to do one of these is I like to start by finding the k, because I remember that y equals k is the midline. So all I'm going to do is use my eyes and look for the midline. So it appears that the midline is right here. Everybody agree with that? And since the midline is y equals k, I know that the k is 1. Cool? Next, I'm going to find the amplitude. Remember, the amplitude is the distance from an extreme point to the midline. If I look at that, my midline's at 1. My maximum's at 3, so I must have gone up 2 units. So the amplitude is 2, and the absolute value of A is 2. So far, so good. Next thing I'm going to do is look at my period. So I think for me personally, the easiest way to look at the period is to go from an extreme point to the next extreme point. Well, next identical extreme point anyway. So like going from this min to that min. And remember, the period is a horizontal distance. So I'm looking at the x coordinates. Starting at pi over 2 and going to 5 pi over 2 is like going from 1/2 to 2.5. How many units did we travel? 2 units. Everybody's okay with that? So here we'd say the period is 2 pi, because our unit is in terms of pi. It's okay? So what I can do with that then is I know that 2 pi times the absolute value of c is equal to 2 pi. So the absolute value of c is 1. So we'll just say c is 1. Leo?
Where do you get the 2 pi on the end of that though? Like 2 pi times c equals 2 pi.
So I'm talking about the distance from here to here,
Yeah.
which is 2 pi. Okay with that?
Yeah.
And again, I'm just kind of counting, right? If you wanted, you could say like the x from the point on the right minus the x from the point on the left or something. Or if you get confused about which one is which, you just put an absolute value between them around it. Like if you reverse the order, it doesn't matter. But it's just like looking for a distance. I like using my eyes because like common sense really is helpful on this kind of thing, right? But again, like if you're a formula dude, like that's a formula for you. Okay, so the last thing we need, we are told that we're using sign here. So we need to find the value for H and then the sign for A. The SIGN for A. So since we're told we're going to use sign, I'm going to use the point 0, 0, which is a midline max. And then for my transform function, I'm going to pick another midline point. So I have lots of options, right? You know, all of those are midline points. I could use any one of those. I'm going to choose to use this one because the coordinate is already identified for me, so I don't have to worry about making a mistake on reading it off the graph. And if I look at this, this is also a midline max point because directly to the right of it is a maximum. Everybody's okay? So what can I conclude about the sign of A? Is A positive or negative? It is positive because they're both the same kind of midline points. So my A is positive 2. And the value for H has to be?
Pi.
Is pi. Since the x coordinate on the parent function is 0, the H is just the x coordinate from the transform function.
Do we need K? Oh, we already have K.
We already got K.
Yeah.
So these ones are nice because the K is basically for free. You can just read it off the graph.
Okay.
So we just looked at the picture and went, oh, there's the midline, so there's my K,
Right.
which is nice.
Yeah.
Ellie, are you happy on that? And these ones are all relatively the same. Like there's not, because you have all the information available to you at all times, these problems are all kind of the same. The ones on the other sheet that we looked at can be different depending on the information that you're given. You might have to take a different approach. Claire?
Why is it 1 over 1?
So the general form here is y equals a times sine of 1 over c, x minus h plus k. So I just wrote, I mean, you don't have to write it. You don't even have to put anything there because 1 over 1 is just 1 and 1 times anything is itself. So like, you don't really have to include that. But I just wanted, like, if I'm writing out answers, I'm going to write it in like the dumbest kind of way possible. So it's hopefully obvious to see what I did. You know what I mean? Or least simple, I don't mean dumbest way, but I mean like least simplified way. Leo.
So say you chose a different midline point for your transform function.
Mhm.
There was a one to the right.
Mhm.
And so now make it middle line or whatever to minimum. And so then A would be negative, right?
Yeah. So what Leo's asking is if we used 2 pi 1, which is a midline min, there the A would be negative and the H would be 2 pi. That's what you're asking, right?
Yeah.
But
Would
that's
you still end up with the same exact answer or like a different answer?
so your answer will have different numbers in it. If you draw the graph though, the graphs for these two things will be identical.
Okay.
That's what's going to be the same. And I'll know when I look at yours. If I have any doubt, I'll just graph it against my answer and make sure that that your thing is doing the same thing that mine is. You know what I mean?
Yeah.
But typically I don't get answers that aren't, in the form that I'm expecting. Does that feel okay? How would this change if I was doing the cosine version?
You'd have to find, it would be harder to find K.
No, all those are identical. All that stuff is identical. The K, the absolute value of A and C, all still the same. The only thing that's going to be different is finding my H and my sign for A. So in cosine, I'm going to use the 0.01, which is a maximum. So I need to pick an extreme point. So I have lots of minimums and maximums. I'm really going to pick between one of those two, though, because they're the labeled ones. So let's say we used pi over 2 negative 1. That's this one here. Which was a minimum. So what's the a got to be in this case? Negative 2. And what's the h got to be?
Pi over 2.
Pi over 2.
Okay, is the parent function of 0, 1 always a max?
So because we're using cosine, we're going to use this.
Yeah. I thought.
And
0,
because we're
1
using sine, we're going to use that. But those are all, that part is always the same. If you're using sine and you're using that point, always that type of midline point. If you're using cosine and you're using that point, always a maximum. You guys think you feel okay?
I'm ready to take the test right now.
Me too.
Okay.
Yeah, we can skip the homework.
It's good to just give me that test.
You're going to have trouble with the tangent stuff that we haven't studied yet.
Tangent got nothing on me.
Sure, let me pass these on now.
When you're sleeping, I'm there.
So just FYI, there's one question on the front and one question on the back.
Oh my lordy lord.
So make sure you flip over and do the back also.
What my pencil case? This is a partner quiz, right?
Not this
In our dreams, maybe.
Work hard, mommy. Good luck. Good luck, daddy. You can start, yes?
Yeah, go ahead. Again, make sure that there's two. This is two-sided. There is one question on the front, one question on the back. Make sure you remember to flip over and do the question on the back. Question number 1, I left a bunch of blanks. You can fill in the blanks, or if they're too small for your penmanship or whatever, you can just write your stuff off to the side. That's okay also. I write really small, and I'm a poor judge of how much space people really need to do things. So if you're like, I can't fit anything in there, then just write it off to the side. It's okay. Hmm.